It's been a while since I've done one of these update videos. I've been busy. Of course, I was making that music video Fuchsia for Ollie Mitchell's. If you haven't checked that out, I recommend you do. But I've also been following a course on YouTube. It's a Dave Churchill's Comp 4300 course from Memorial University. It's a C++ game programming course. I've learned a lot about C++, okay? From the basics up to creating my own game engine using an ECS, entities, components, and systems architecture. One of the things covered in Comp 4300 was raycasting. Most simply, that involves drawing lines and seeing if they intersect. Raycasting is used a lot in games to check things like line of sight. So, I created a simple C++ game that includes lights that can cast shadows. As the player moves about, they cast a shadow in real time behind them. World geometry also casts shadows. Lights have a limited range and field of view. The game also includes cameras. The camera responds if it can see the player, but it also responds if it sees the player's shadow. How? If I turn on the debug view, you can see that the player's shadow is actually its own object. Typically, this object is invisible, but not to the camera, which checks to see if any of the shadow lines are within its field of view. These real-time light and shadow shapes allow for complex interactions between the player and geometry, making it viable for the player to be within a light cone, but having his shadow be blocked by a wall before it hits the camera. After doing this, I looked at the Unreal Engine version of Boom Operator, and I had an epiphany. I didn't need to make the whole light shape. The engine handles the rendering of lights and shadows for me already. I just needed to create the shadow shape for each light, each frame. The camera can then check to see if it sees the player directly or any of the shadow shapes. I made a new scene to test the shadow system. It's a typical Robert Stack walking monologue, but with lightning strikes happening on cue in the background. The lightning causes the player to cast a shadow. The camera will see that shadow unless the player hides behind a bush. Timing movement between bushes while keeping the target on mic is a unique challenge. In summary, there's some irony here at the core of this video. I learned a bunch about C++ and some fundamental programming concepts, allowing me to solve some of my long-held game design problems. But at the end of the day, I solved those problems in Blueprint, not C++. Considering I added the new shadow casting system in an afternoon after not touching the project in nearly a year, I might be able to rewrite the whole thing in C++ in a few weeks. But those are famous last words, and a bird in the hand is often worth two in the bush. The game already works. Maybe it's time just to focus on content.